In this video, we'll see few sums that are related to trigonometric ratios. What are trigonometric ratios? Sine, cos, tan, secant, cosecant, cot. These explanations, how we are getting these ratios, I have given you in the previous video. Okay, based on those ratios, we'll be doing few sums. Those sums are very important. Okay, these are the four sums we are going to do. Given 15 cot A is equal to A, find sin A and secant A. Second sum, if angle B is equal to angle Q or acute angles such that cos B is equal to cos Q, then show that angle B is equal to angle Q. Third sum, in triangle ABC, right angled at B, if tan A is equal to 1 by root 3, find sin A cos C plus cos A sin C. In triangle PQR, right angled at Q, PR plus QR is equal to 25 and PQ is equal to 5 cm. Determine the values of sin P, cos P, tan P. Okay, one by one we will see. Now we'll see the first sum. First sum is given 15 cot A is equal to 8. Find sin A and secant A. So for finding sin, we need hypotenuse side. Cot A. If you take cot A is equal to 8k by 15k. Since this is in ratio, it will be 8k and 15k. Some ratio only. So 8k by 15k. Cot A is equal to 8k by 15k. So what is cot? Cot is adjacent by opposite. So if you take a right angle triangle, cot A, B, C. So 80, this one is adjacent. Adjacent by opposite side. So adjacent for this is, here it will be 8k and here it will be 15k. So you need to find the hypotenuse side. That is AC is equal to root of AB squared plus BC squared. So what is AB squared value? 8k the whole square plus BC is 15k the whole square. So when you simplify this, you will get 64k squared plus 225k squared. It will be 289k squared. Okay, so that is equal to, when you bring it out, it will be 17k units. Okay, it will be 17k. So now you got the value for hypotenuse as 17k. Now it is very simple. You have to substitute it in this. You are asked to find sin A value. So sin A is, what is sin A? Opposite by hypotenuse. Opposite by hypotenuse. Opposite for that is 15k. 15k by hypotenuse is 17k. So when you simplify this, you will get 15 by 17. So this is your sin A value. Okay, then secant A. What is secant? By hypotenuse by adjacent. So what is hypotenuse? 17k by adjacent. What is adjacent side? 8k. So that is equal to 17 by 8. So this is how you have to find. If they are asking you to find C values and all, sin C, the same procedure only. Since you know all the three values in this Pythagoras theorem, that is opposite. If you want to find sin C, opposite will be this, adjacent will be this, hypotenuse will be same. Accordingly, whatever thing they are asking, you can able to find with the help of this. So if any two values are given, you will find the other one using Pythagoras theorem. Substitute it in the ratio. You know sin, cos, tan ratios. Substitute it in that and find. If angle B and angle Q are acute angles such that cos B is equal to cos Q, then show that angle B is equal to angle Q. So for proving this, we will take two triangles. Two right angle triangles. Okay. So first one is A, B, C. So B is here and P, Q, R. Your Q is here. Okay. It is given that angle B and angle Q are acute angles. So you are taking angle B in two triangles, in two different triangles. You are taking angle B and angle Q. It is given that angle B and angle Q are acute angles such that cos B is equal to cos Q. So it is given that cos B is equal to cos Q. Cos B is equal to cos Q. So what is cos ratio? Cos ratio is adjacent by hypotenuse. So cos B is adjacent side by hypotenuse side. So adjacent is, our adjacent is BC by hypotenuse side is AB. So BC by AB is equal to, in Q, same thing, adjacent by hypotenuse. So adjacent is QR. QR by PQ. Okay. So it is given that BC by AB is equal to QR by PQ. Okay. Now we can rewrite this as BC by QR. BC and QR. BC by QR. Okay. BC by QR is equal to, just we are rewriting it. BC by QR is equal to AB by PQ. So we are telling that this ratio is equal to some K constant. Okay. So we take this as first equation. So BC by QR is equal to AB by PQ is equal to some constant K. So this is our first equation. Okay. This is equal to K. Now the other one is there. Pythagoras theorem. We will be using Pythagoras theorem, and in Pythagoras theorem we can write AC value as, how will you write AC? AC is equal to root of AB squared. AB squared is hypotenuse. So AB squared minus BC squared. So you will write AC as, AC is equal to root of AB squared minus BC squared, and you will write PQ. PQ value as, you will write PQ, not PQ. You will write PR, the other side. You will write PR as root of PQ squared minus QR squared. PQ squared minus QR squared. When you are finding the ratio of this AC and PR, AC by PR is equal to, what we got for AC, we are writing it AB squared minus BC squared by, what you got it for PR? PR, you got it as PQ squared minus QR squared. Now what we got? Here AB. AB by PQ is equal to K. So now I am replacing this AB as K into PQ. Here I am replacing AB squared is equal, AB is equal to K into PQ. So root of K squared PQ squared minus BC. So what is BC? BC is equal to K squared QR squared. K squared QR squared by root of, so we'll write it here, BC by QR is equal to AB by PQ is equal to K. So this we got it as the first equation. Okay, so now just I am writing PQ squared minus QR squared. So now when I am writing it, this K squared is common in this. So I am taking that out. So when I am taking it out of the root, we will get K. So K is equal to root of PQ squared minus QR squared by root of PQ squared minus QR squared. So when you cancel this, you will get AC by PR is also equal to some constant K. AC by PR is also equal to some constant K. Already what we have given, the other two sides are equal, we said. Other two sides, BC by QR is equal to AB by PQ. That value is equal to K we told. Now we are telling the third side is also equal to some K. So finally, what is the thing? AC by PR is equal to BC by QR is equal to AB by PQ. So all are equal. So what is the question we asked to prove? So since all the three sides are of the triangle are equal, so triangle are in equal ratio, all the three sides of the triangle are in equal ratio, the angles will be equal. That is the property of similar triangle. So we have proved that angle B is equal to angle Q. This is the thing they are asked to prove. What is the question given? Cos B is equal to cos Q. From that, they are asking you to derive angle B is equal to angle Q. So this is similar triangle property. All sides are in ratio. All sides are in some ratio is equal to some K. So all three sides are in some ratio. So angles will also be equal. This is the proof. Okay, sir. In a triangle ABC, right angled at B, if tan A is equal to 1 by root 3, find the value of sin A cos C plus cos A sin C. Okay, so now triangle. Right angled at B. So this is here A, B and C. In the question it is given tan A is equal to 1 by root 3. So what is tan A? Tan A is opposite by, so here it is A. Tan A is opposite by adjacent. So what is opposite value given? Opposite value is given as 1. Okay, 1K, some constant K, since it is in ratio. And tan A, this is adjacent is given as root 3. Okay, so you will be finding the value of the hypotenuse now. So how will you find using Pythagoras theorem? AC squared is equal to root of AB squared plus BC squared. So AB squared is root 3 the whole squared, K squared plus BC is 1K squared. So root 3 whole squared will be 3. 3K squared plus 1K squared. So you will get 4K squared. Root of 4K squared. So you will get 2K. So what is the hypotenuse you will get? Hypotenuse value is 2K. Hypotenuse value is, you will get 2K. So you got the value for 2K hypotenuse now. Now they are asking you to find sin A cos C. So sin A and cos C. Sin A cos C plus sin A cos C plus cos A sin. Now we will substitute this in the given question. Sin A cos C plus cos A sin C. So for sin it is opposite by hypotenuse 1 by 2 into cos C. Cos C is adjacent by hypotenuse. So cos C, for cos C adjacent is this side 1 by hypotenuse plus cos A. So for cos A it is opposite by hypotenuse. For cos A opposite for cos A it is adjacent by hypotenuse. So adjacent side is root 3, hypotenuse is 2 into sin. For sin it is opposite. For sin C it is opposite side. For sin C it is opposite by hypotenuse. So that also opposite side is this one. For sin C opposite side is this one. So that is root 3 by 2. So depending upon the angle, opposite and adjacent will interchange. So you will be getting like this. So sin A and cos C values are equal and cos A sin C values are equal. Understood? So this one you will get, this is multiplication. So 1 by 2 into 1 by 2 will be 1 by 4 plus root 3 into root 3 will be 3 by 2 2s are 4. So when you simplify this, you will get 4 by 4 value is 1. This is your answer for the given question. Fourth sum is, in triangle PQR, right angled at Q, PR plus QR is equal to 25 centimeter, PQ is equal to 5 centimeter. Determine the values of sin P, cos P and tan P. In the previous sum, sin, cos, if tan some values will be given. From that you will find the third side, substitute it in the given thing and you will get the answer. But here, two values, two sides length is given together. See here. So you take a triangle PQR, right angled at Q. So the right angle at Q, so PQR. Then PR plus QR is equal to 25 centimeter. That is, PR is this side. This side. QR is this side. PR plus QR is 25 centimeters. Sum of these two sides is given as 25 centimeter. And PQ is given as 5 centimeter. This is the length given. Okay. Determine the value of sin P. So if you know all the values separately only, you can substitute it in this trigonometric ratios. That is, three sides of the triangle length you have to know. For that, in the question it is given, these two sum is given as 25 centimeter. Okay. So you take any one value as x. So you take QR is equal to x. You take that as x value. Substitute that x here. So you will get PR value as 25 minus x. Since you have substituted QR value as x, PR value will be 25 minus x. Now you use Pythagoras theorem. So what is Pythagoras theorem? PR squared is equal to PQ squared plus QR squared. This is your Pythagoras theorem. This Pythagoras theorem, hypotenuse squared is equal to sum of the squares of the other two sides. So PR value what we have taken? 25 minus x. 25 minus x the whole square is equal to PQ value is given as 5 squared plus QR. QR value you have taken it as x squared. So here using a minus b the whole squared identity. What is a minus b the whole squared? A squared plus b squared minus 2ab. So a squared. A is 25. 25 squared is 625. 25 squared is 625 plus x squared minus 2ab. 2ab is 25 into 2 is 50. 50x is equal to 25 plus x squared. So when you simplify this, x squared and x squared will get cancelled. So 625 minus 25 is equal to 50x. So 625 minus 25 is 600. 600 by 50x. So when you simplify this, 600 by 50 will be 12. 600 divided by 50 is 12. So your x value is 12. Now you substitute this x value here. So you got QR value as 12 centimeter. So here you got it as 12 centimeter. And PR is 25 minus 12. That is 13 centimeter. So this one is 13. Okay. So now you got all the three values. Now you find sin P. What is sin P? Sin P is P is here. Isn't it? Sin P is opposite by hypotenuse. So opposite side is 12 by hypotenuse is 13. Okay, now it is simple. Then cos P. Cos P. Cos P is adjacent by hypotenuse. Okay. Adjacent 5. Hypotenuse is 13. Then tan. Tan P. Tan P is opposite by adjacent 12 by 5. So this is how you have to simplify this and find the values of sin p, cos p and tan p. So these are the 4 varieties of sums we have learned today using trigonometric ratios. All varieties of sums is covered in this 4 sums. If you know all these things, it is more than enough. Thank you.